somewhere in the deep past, long before antihistamines, long before epinephrine injectors, long before anyone had a word for anaphylaxis, a human being reached into a hole in a tree and pulled out honeycomb. And the bees that lived there did exactly what bees do when something large and threatening invades their home. They attacked. And that human had to have a plan, because they kept doing it. For tens of thousands of years, across every continent where bees existed, humans went back to the hive again and again, accepting the stings and the risk, because what was inside was worth it. Honey is one of the most calorie-dense foods in nature. Beeswax has dozens of practical uses, and the persistence with which ancient humans sought out bee colonies, despite the obvious dangers, tells us something extraordinary about the knowledge they developed to manage those dangers. The real answer to how ancient people avoided bee attacks is far more sophisticated than most people imagine. Start with the oldest evidence we have. Rock art from the Cave of the Spider in Valencia, Spain, dated to at least 8,000 years ago, depicts a human figure climbing a cliff face toward a wild bee nest, surrounded by bees, with what appears to be a basket or bag in hand. This is one of the earliest known images of honey hunting in human history. And what is remarkable about it is not just the activity it depicts, but what it implies. The figure is calm. The figure is purposeful. The figure has done this before. Because the thing about bees, and this is the foundation of everything ancient humans learned about them, is that they are not random. They are predictable. They respond to specific stimuli in specific ways. And a person who understands those stimuli, who knows what triggers an attack and what prevents one, is not gambling with their safety every time they approach a hive. They are managing a known system. The single most important discovery that ancient honey hunters made, and we know they made it because it appears in the ethnographic record of virtually every honey hunting culture ever studied, was fire. Bees respond to smoke in a specific and well-documented way. When smoke enters a hive, the bee's first instinct is to gorge on honey. The evolutionary reason for this is straightforward. Smoke signals fire. Fire means the hive might be destroyed. Bees preparing to flee a burning tree cannot afford to abandon their food supply, so they eat as much honey as possible before leaving. A bee that has gorged on honey is physically less capable of bending its abdomen to sting. It is also, neurologically, in a different state. The distress signals that coordinate defensive attack behavior are suppressed. The ancient honey hunter, who first understood this connection, who noticed that bees near a smoky fire behaved differently than bees near a clear flame, who then deliberately introduced smoke to a hive before approaching it, made one of the most practically important observations in human history. This knowledge traveled. Archaeological evidence from ancient Egypt shows images of beekeepers using smoke as early as 2400 BCE. Ancient beekeeping sites across the Middle East, in Greece, in India, all show evidence of smoke use. But the practice almost certainly predates organized beekeeping by thousands of years, because wild honey hunting with smoke appears in the ethnographic record of cultures that never developed beekeeping at all. The San people of southern Africa, the Hadza of Tanzania, the Gurung honey hunters of Nepal, all use smoke in ways that appear ancient and deeply embedded in tradition. But smoke is only one part of the picture. Ancient honey hunters also understood the biology of bees in ways that gave them practical advantages. They knew that bees are significantly more aggressive in certain conditions and significantly calmer in others. They knew that hot, still afternoons make bees defensive, while cool mornings make them sluggish. They knew that bees that have recently been disturbed are far more likely to attack than undisturbed colonies. They knew that dark colors and strong smells, particularly animal smells like sweat and breath, provoke bees, while calm, slow movement and pale or light-colored clothing reduce the threat signal. The Gurung honey hunters of Nepal, who harvest honey twice a year from massive hives built on vertical cliff faces hundreds of meters above the ground, represent one of the most extraordinary examples of accumulated human knowledge about bee behavior ever documented. Their methods, passed down across generations, include specific approaches for reading the mood of a colony before attempting to harvest, specific body positions and movements designed to minimize threat signals, specific timing based on season and weather, and specific techniques for managing smoke in ways that calm without panicking the colony. This knowledge is not written anywhere. It lives in bodies and hands and the careful attention of people who have watched bees for their entire lives. There is another dimension to this that is less obvious but equally important. Ancient humans also developed relationships with other species that helped them find and access bee colonies more safely. The honeyguide bird, found across sub-Saharan Africa and parts of South Asia, has one of the most remarkable interspecies relationships with humans in the natural world. The greater honeyguide actively guides humans to bee colonies by calling in a specific way and flying toward the hive, waiting for the human to follow, then calling again. In return, the human exposes the beeswax and larvae inside the hive, which the honeyguide cannot access alone. This relationship has been studied extensively by researcher Claire Spottiswoode at the University of Cambridge, whose work has documented that honey guides respond specifically to the signals of human honey hunters, distinguishing the calls used by honey hunters from other human sounds. The relationship appears to have been established thousands of years ago and is still active today among certain communities in Mozambique and Zimbabwe. This means that ancient humans were not just tolerating bee attacks and managing them with smoke. In some cases, they were navigating to bee colonies with the help of a bird that had evolved a specific behavioral partnership with their species. Ancient people also developed protective measures. Evidence from various traditional cultures shows the use of clay, mud, and plant materials applied to the body or worn as coverings to reduce the number of exposed skin surfaces during honey hunting. Some cultures smeared animal fat or specific plant oils on exposed skin, possibly to mask human scent. Some wore specific plant materials around the head and face, and some, documented across multiple cultures, simply learned to endure the stings with practiced calm. Because panic is exactly what makes a bee attack worse. A person who swats, who runs, who makes sudden movements in response to a sting, sends precisely the alarm signals that recruit more bees to attack. A person who moves slowly and deliberately, who absorbs the first stings without changing their behavior, can sometimes complete a honey harvest under conditions that would send a panicking person to the ground. This takes practice. It takes knowledge. It takes a specific kind of courage that is less about bravado and more about accumulated understanding. Understanding that the system is manageable. Understanding that the bees are responding to signals and that you can control those signals. Understanding that what looks like chaos from the outside is, from the inside of the knowledge, a set of rules that can be worked with. Ancient people did not avoid bee attacks by staying away from bees. They avoided the worst bee attacks by becoming, over generations, the kind of people who understood bees well enough to go where they lived and take what they needed and come home. The honey in the hive was always worth it, and the knowledge to get it safely was one of the most valuable things a community could possess.